once again. Welcome to Physics Calculation Center. I hope you are following us on our various calculations. This afternoon we'll continue with our uniform acceleration. Then we'll continue with some questions, some examples on uniform acceleration. Let's take this question. And this uniform acceleration we're doing is still under the first law of equation. Remember we did first law of equation that says first equation of motion. First equation of motion. Just to refresh you, first equation of motion, where I said this is final velocity, and I call this initial velocity, and I said this is acceleration, and I call this time. This is called first equation of motion. First equation of motion. Just to refresh your memory. Having said that, then let's take another example. Okay. A particle accelerates uniformly. A particle accelerates uniformly from rest. Accelerates uniformly from rest at 6 meters per second square. At 6 meters per second square for 8 seconds. And then decelerates uniformly to rest. And then decelerate uniformly to rest in the next 5 seconds. Determine the magnitude of the acceleration. Determine the magnitude of the acceleration. The magnitude of the deceleration. Okay, and we know deceleration has to do with negative acceleration. Okay, the first thing I told you is for you to get the parameters. Okay, if you look at this, it's saying a particle accelerates uniformly from rest. And I told you when a particle starts from rest, the initial velocity is 0. When it starts from rest, it is 0. And we have the acceleration as 6 meters per second square. We have acceleration as 6 seconds. And the time is 8 seconds. And it says we should calculate. Okay, and the time is 8 seconds. Now it says we should calculate the deceleration. And we're going to be using V equals U plus 8C. First equation of motion. V equals, because it is uniform acceleration. So the first thing you need to do is, now if you look at this now, you see we have initial velocity, which is 0, but we don't have the final velocity. Okay, but we have acceleration and we have time. Beautiful. So having gotten that, we need to find the final velocity, which will enable us find the deceleration. That is just common sense. Because now we have the initial velocity, we have the acceleration, we have the time, but we don't have the final velocity. So the first thing we do is for us to do what? To find the final velocity. Now, V equals 0, which is the initial velocity, plus 6, which is the acceleration, times the time. Okay, which will give us V equals 48 meters per second. Beautiful. So having found this now, I have the initial velocity, I have the final velocity, I have the acceleration, I have the time. So I can determine the magnitude of acceleration. Using the same first equation of motion, which says V equals U plus 8C. Now our initial velocity it says the time magnitude of deceleration. Now we have the final velocity, which is 48 equals U plus the acceleration is 6. No, we are looking for the deceleration, okay? The deceleration is what we are looking for. And I've told you that deceleration is the same thing as negative acceleration. The same thing as negative acceleration. And this one is, it says, look at this question. It says, and then decelerates uniformly to rest, and then to rest. So what that simply means is this. What that simply means is that the final velocity now is now 0. Final velocity is 0. Final velocity is 0 because it decelerates, it reverses, and came to rest in the next 5 seconds. So using v equals u plus 8c, the final velocity now is 0. The initial velocity is now the final velocity we got from the last calculation. So that's 48 plus 5 seconds, sorry. We have used the 5, okay? The 5 seconds, yes, it's 5 seconds. So acceleration is now times 5 seconds. Beautiful. Times 5 seconds. So now 48 will come to this side. 48, which is minus, equals 5a. So it's because we are looking for acceleration. This will be a equals minus 48 over 5. So minus 48 over 5 will give us minus 945,330.6. Minus 9.6 meter per second square. The minus there shows that it is decelerating. The minus there shows that it is decelerating. In our next video, we'll be looking at the second law of the equation of motion. Thank you.